Hello class, welcome to our lesson today dealing with section 4.2. This deals with translations of the graphs of sine and cosine. So in section 4.1, we mainly just took the period and amplitude and changed those on a graph. Today we're going to talk about translations, so moving things to the left or right or up or down. We're going to spend a couple days on this lesson because of the different types of questions that could be asked, and honestly it's probably just good to review the same ideas multiple times. First thing to look at is a vertical shift. A vertical shift will be kind of out front by itself, and it'll be a number addition or subtraction. That value is denoted by the letter C, but it also could be after the trig function. C is the vertical shift, so it moves up or down in a certain amount. If C is positive, it's going to move up. If C is negative, it will move down. So this graph here has 3 plus sine x. Notice there's nothing in front of the sine after the addition symbol, so the amplitude is still 1, the period is 2 pi. That's a normal sine graph. But the graph has moved up 3. So you can think of this as the regular sine graph, just all the numbers are shifted up 3. So I briefly have the sine graph here in kind of a dotted blue line, and then all the points are moved up 3. This new location of 3 is really the equilibrium, or the middle ground of the graph, and then it should go up and down from there. But it's literally just taking all the points, so I take these main points and move them all up 3, and it will be the same sine graph, just shifted upward. The next one is cosine of x minus 2. Notice this minus 2 is after the cosine of x. That's still a vertical shift, and that's moving down 2. So the amplitude is 1, the period is 2 pi. When you're using the Math Excel information, when it says vertical shift, sometimes you have to type it in as just negative 2. Okay, in these cases, because what you're saying is if it was 2, it's going to go up 2. If it's negative, it's going to go down. So you want to pay attention to that as you're looking at some of your homework questions as well. Notice this is the same graph as cosine, but all the points are just moved down 2. So it should be the same graph, just kind of picked up and copy and pasted downward in 2. The next thing we need to talk about is what's known as a horizontal or a phase shift. The phase shift is the letter D inside, and notice it's in parentheses. So D in this case, if it was minus D, that's actually a shift to the right. And if it's plus D, that's a shift to the left. This should correspond, if you think back to your algebra classes, with things like parabolas and vertices of circle and of a center of circles. So those ideas are similar, where it was always kind of backwards inside of the parentheses. So for this question, it's sine of x minus pi over 4. The amplitude is 1, the period is 2 pi, so those pieces are identical. And then this minus pi over 4 would move everything to the right pi over 4. That corresponds to D being pi over 4. I put the dots of the original sine graph here, and then all I've done is taken all these dots and moved them to the right pi over 4, and it should make the same graph. So it's like you pick it up and move everything over pi over 4 to the right, and that would be the graph of sine of the quantity x minus pi over 4 equals y. The next one is cosine x plus pi over 2. So the amplitude is 1, period is 2 pi. This moves to the left pi over 2, and if you have to plug that in, that's a phase shift of negative pi over 2. So to the left is the same as a negative phase shift. A regular cosine graph would start up here at 1, and I move all the points over to the left pi over 2. So it's just picked up and moved over a little bit in order to figure out what that cosine graph would look like. The next question has an amplitude of 3, and you have to move everything to the right of 3 pi over 2 because it's minus 3 pi over 2. On my graph paper that I have here, I run out of space. So if I move everything to the right 3 pi over 2, here's 0, 0 for sine. If I move to the right 3 pi over 2, that puts me here, and the graph should go up and back down, etc. I'm out of space, though, so I kind of have to work backwards, and it has to match up. So the sine graph to the right of the equilibrium 0, 0 location should be going in the upward, and as you go back, go downward. The other thing is that the amplitude is 3 here, so from equilibrium, which is this middle ground, I should go up and down 3 from that location. So it's important to make sure you recognize a little bit more as you're looking at the graphs of these functions to ensure that you're finding the correct period, amplitude, phase shifts, and vertical shifts. This next one has a phase shift or a horizontal shift of left pi over 4. That would correspond to D being negative pi over 4. And then notice here it has minus 3. That should just move everything down 3. So this is a regular cosine graph, so I put these dots here to represent the regular cosine graph that we've talked about in the past. Then I needed to move all the points to the left pi over 4, which in this graph paper is just one location. to the left pi over 4 and down 3, and I just do that for all the main locations, and that's where it should be. Anytime you move up or down, that's when the equilibrium changes from the x-axis. So notice here, I even put a dotted line here to represent, oh, that's the new equilibrium location. So everything amplitude-wise, notice it's above 1 and down 1 from that dotted line. This is a combination of all the things at once if you're looking for a quick guide to figure out what you're looking at. Remember, A is the amplitude and its absolute value. B, 2 pi over B would be the period. Horizontal shifts would be the C out front by itself, and the minus D would be the horizontal shift. When you're checking your pieces on your homework, you want to make sure that you're looking and looking for the right numbers in the right locations. So if it's in parentheses, that should affect the horizontal shift or phase shift, as opposed to the C value out front by itself or at the end, not in parentheses. And that should be a vertical shift versus horizontal. These two questions cover one aspect of graphing that's important, and it deals with factoring. If you'll notice on this first question, the 3 is out front. That's the coefficient, so that's the amplitude. The period should be 2 pi over the b value, which is the number in front of x, which would represent this 4. So 2 pi over b, or 4, would be pi over 2. And then this should be a phase shift, or horizontal shift, to the right, 1/2. The second one has 5. That's the amplitude. It has a period of 2 pi over 4, so same as this one. Okay, so 4x divided by 4, you get 2 pi over 4, which is pi over 2. But notice in this circled area, it's 4x plus 5, and notice compared to this one, this is 4 times the quantity. In order for you to get phase shifts correct, you have to factor it out. So if there's a coefficient in front of x, you have to essentially take out a 4 from both pieces, which all that's going to do is divide the second number by 4. Okay, if this was 7, it would be 5/7. If it was 10, it'd be 5/10. Since it's 4, it's 5 over 4. And so you're not moving to the left 5, you're only moving to the left 5/4. And it's important to realize that the equation always has to look like that. It's similar to ellipses and hyperbolas and things of that nature, that you have to factor it, okay, in order for it to be successful about translations. And so one thing you may want to write is these two examples and make sure you realize, oh, I got to factor that out to figure out what the translation is for the equation. That should cover what we need for this section for today. We're going to spend more time about figuring out how to deal with translations, what the graphs look like, and how to find the period and amplitude of translated graphs. Have a good day, everybody.